So if you read the products, the cell to product, independent cell, hence it is A complement B complement C D complement. Cell 2 is, you can see A complement, B complement, C D complement. 4, 5. 4, 5 we are looking as A complement, B, C complement. 11, 15 we are reading, you can check with the binary format or with this as per your convenient. Okay, so D changing, it won't present, and we are looking to the ABC value 0, 1, 0, so that A complement, B, C complement. Coming to the 11, 15, similarly, it is ACD. ACD. Coming to the 4 cell subtube, it is BD. Now, we are taking OR operation among all these products. While taking OR operation among all these products, we are looking here. This is BD, R with ACD, R with A complement, BC complement, R with A complement, B complement, C, D complement. So this is the minimal SOP expression for the function f of ABCD. It is the minimal SOP expression for the function f of ABCD. Now, while looking to all these examples, we can speak few conclusions. With all this work, we can speak few conclusions based on the observations what we are having from these examples. We are having here, it is a function on 4 variables. It is a function on 3 variables. It is a function on 2 variables. And we are looking, these are the subcubes with the 2 cells. When we are having subcubes of 2 cells, M value is 1. The products we are reading here with the 3 literals. Products we are reading with the 3 literals means we are having elimination for how many variables? We are having elimination for how many variables? The answer to this is 1 variable, because the function is on 4 variables. The products we are reading with the 3 literals, hence elimination we are having for 1 variable. Similarly, in this 3 variable Boolean function also, we are having the subcubes of 2 cells. We are having here also subcubes of 2 cells, that is M is 1. And the products what we are reading here, the products are with the 2 literals. Once the products are 2 literals, we are able to speak now. Here also elimination we are having for 1 variable. Here also we are having elimination of 1 variable. Because the function is on 3 variables, the products we are reading the 2 literals. So elimination we are having for 1 variable. Similarly, for this 2 variable Boolean function, we are having subcubes of 2 cells, that is M is 1 here also. Products, if you look here, products we are having single literal. So elimination we are having here, elimination if you speak, here also we are having for elimination of 1 variable. Hence, the function may be on 2 variables or 3 variables or 4 variables. Function may be on any number of variables. As and when we are having the subcubes of 2 cells, that is M is 1. As and when we are having the subcubes of 2 cells, we are having elimination for 1 variable. We are having elimination for 1 variable. Hence, we are speaking here now, whenever the function, whenever we are having function on any number of, whenever function may be on any number of variables, if the subcubes are size of the 2 cells, we are having elimination for 1 variable. We are having elimination for 1 variable. Similarly, in this 4 variable function, we are having a subcube of 4 cells. Once we are having a subcube of 4 cells, we know well m is 2. The product we are reading 2 literals. So elimination is for 2 variables. In this 3 variable example also, we are looking a subcube of 4 cells. One subcube is a size of the 4 cells, m is 2. Product is with a single literal. Once the product is with a single literal, we are looking here also elimination for 2 variables. Function was on 3 variables. Product single literal. So elimination is for 2 variables. So the function may be on any number of variables. As and when we are having the subcubes of 4 cells, we are having elimination for 2 variables. As and when the subcube is of size 4 cells, we are having elimination for 2 variables. So based on this, if the question, if you take for this 8 cell product, how many number of variables are eliminated? If it is the question for this 8 cell subcube, how many number of variables are eliminated, will be eliminated, if that is a question. So based on this work, you need to speak, the answer must be 3, because whenever we are having 2 cell subcube, it was with the m value as 1. Whenever the subcube is of 4 cells, it was with m value as 2. If m value is 1, we are having elimination for 1 variable. If m value is 2, we are having elimination for 2 variables. If for 8 cell subcube, if you look, m must be 3. For 8 cell subcube, we must read m as 3. If m is 3, we will be having elimination for 3 variables. If m is 3, elimination is for 3 variables. So that for 8 cell subcube, we are having elimination of 3 variables. While looking to this, we have to look more generic statement. So just note down as a question and you try to give the answer to this question. It is one of the important question. Such things you can expect as the questions in the question papers. So something which was not asked till now, try to focus on such questions. The question what I am going to mention now, till now in GATE paper or any PSU paper, it was not the question. So something which was not appeared in the earlier papers, you must expect with the importance. And this is concept-based question basically. So note down. In a function of n variables, note down, in a function of n variables, consider a possible subcube of, consider in a function of n, in a function of n variables, consider a possible subcube of 2 to the power of m cells. In a function of n variables, consider a possible subcube of 2 to the power of m cells. Put comma. The subcube product is represented. The subcube product is represented. The subcube product is represented with how many number of literals? The subcube product is represented with how many number of literals? The subcube product is represented with how many number of literals? So, what is the answer for this question? For this question, what must be the answer? The question is, in a function of n variables, we said a possible subcube of 2 to the power of m cells. The question what we are looking is, the subcube product is represented with how many number of literals? So, when the subcube is of size 2 to the power of m cells, then elimination we are having for m number of variables. We are having elimination for m number of variables. Elimination is from where? Elimination is from n. So after eliminating m number of variables from n, how many variables are present? N minus m number of variables are present. So answer to this question is n minus m. After eliminating m number of variables from n, the remaining number of variables must present. So the product must present with n minus m number of literals. Hence, answer to the question is n minus m. Okay. Now, let me discuss another point I said we will be discussing later. That point is specifically after 0, 1, why we are not taking 1, 0 and so on here 1, 1. It was a question. The same thing even for rows. After this 0, 1, why can't 1, 0 and later 1, 1? With all the discussion on the K-map till now, what we did, your understanding supposed to be the K-map work what we are having here, the K-map work what we are looking here, that is basically in need of looking to the adjacent cells. For grouping, the work what we are having is grouping of the cells. For grouping of the cells, our concern is reading easily the adjacent cells. So, with the grouping of the adjacent cells, we are basically having elimination, of course, using so and so condition for while marking the subcubes. So, basic purpose is easy reading for adjacent cells, right? If at all we use 1, 0 here, then definitely these two cells are not going to be adjacent cells. The reason is they are different variable C as well as D. They are different C as well as D. And similarly, whenever you are folding, because of 1, 1, these two cells are not coming to be adjacent cells. The same thing holds good even here also. If we take 1, 0, 1, 1, this order, it is only the reason, not any hidden thing involving there. The map is basically developed for easy readability for the adjacent cells. We are having easy readability for the adjacent cells with these headings 0, 0, 0, 1, 1, 1, 1, 0. Black color what we are looking even here also. That is the only reason. So no need to bother anything much, and you no need to make any screwing as a big thing. Nothing big thing there. And maybe you may be talking sometimes it is to follow gray code sequence. Okay, all those are maybe correct, but I didn't mention gray code, so why I supposed to use the wording of the gray code? The things what we learned we have to use. Our concern is reading easily the adjacent cells. That is possible if at all the headings are so and so. That is enough to speak, to understand. Okay, so it is the reason why we are having the headings as so and so. The K-map may be with any number of variables. It is a thing what we are looking. So the basics what to discuss with the K-map about how to mark the subcubes and how to read the products for the subcubes. After this, let us come to the further work on the K-map. So basically, conclusion is using K-map, we are trying to read the minimal expressions. While dealing with the minimal expressions, we come across very frequently some terminology. While dealing with the minimal expressions, we'll be having the usage of the terms implicant, prime implicant, essential prime implicant. These are the words we come across very frequently while dealing with the minimal expressions. And very frequently, you'll be having questions in the GATE paper, or for that matter, in any competitive examination, you'll be having the questions using this terminology. The question may not be coming just while giving some sort of function, what is the minimal form? That is not the case. The question is coming while giving this sort of function, you'll be having a question. The function is having how many number of products as the prime implicants, or the given product is a prime implicant or not for this function, or a given product is an implicant or not for this function, or for a given function, how many number of products are the essential prime implicants, or while giving a product, whether this product is essential prime implicant or not for the given function. This sort of questions you'll be having. So it is a conceptual thing here in the K-map. Most of the students are familiar how to read the minimal expression for the given function. That is not the big thing for many students. But when the questions are coming to that level, what I said, while giving a product, the question is coming to check whether the product is implicant, or whether the product is a prime implicant, or whether the product is a essential prime implicant, or while giving a function, how many products are the prime implicants, or how many products are the essential prime implicants. If such questions are coming, students are little uncomfortable. So let us discuss those things. And if you see the previous GATE solution previous GATE questions from the GATE solution book, couple of times you are having questions related to this terminology in the GATE question papers. Couple of times. Very frequently, very common. 2017 there was a question, 2015 there was a question. Very common, very regular questions these are. So let's start the meaning of implicant first. So let us go one by one about all these terms what I mentioned on the board. Let me start with the implicant. Note down. For the given Boolean function, a product is said to be, for the given Boolean function, a product is said to be implicant of the function. For the given Boolean function, a product is said to be implicant of the given function. For a given Boolean function, a product is said to be implicant of the given function if it covered by the function f. 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 It means, suppose I am having a product H. This product H, we are talking it is implicant of the given function f. We are talking it is implicant of the given function f if it covered by the function f. If it is covered by the function f. So let us try to look to the meaning of this with an example. Let us take a function f which is on the 4 variables a, b, c, d. For this function, the minterms we are having as 1, 2, 5, 7, 10, 11, 13 and 15. These 8 combinations are the minterms of the function f. For this function, let us try to look first the minimal expression. One of the minimal expression, let us try to look. After reading one of the minimal expression, let us try to look to the meaning on this example, the word implicant. With an example, let us try to look to the means. So for this function, let us read the minimal expression. Of course, to read the minimal expression, we need to use the 4 variable K map. So it is the 4 variable K map for this function f. Now, for reading the minimal expression, the procedure what we mentioned is, we are trying to look first independent cells, later 2 cell subcubes, later 4 cell subcubes, and so and so. And whenever we are going step by step, the condition is, whenever we are marking a subcube of to the power of m cells, that should not come as a part of any larger size subcube. That condition we need to follow. So with all that knowledge, the few of the examples what we discussed earlier, let us come quickly here. We are not having here any cell as an independent cell. No independent cell. We are having here a 2 cell subcube. One 2 cell subcube we are having with a grouping of this 1, 5. Other 2 cell subcube we are having the grouping of this 10, 11. And we are having this 2, 10 also one 2 cell subcube. So let me basically trying to read the minimal form. So I am having here one 4 cell subcube. Now, while taking R operation among all these products, we are having possibility to write one minimal expression. The product form for this is BD. The product form for this is A complement C complement D. The product form for this is B complement C D complement. Make a check if any by mistake, if anything is going wrong, rectify yourself. Hopefully it should not happen. So B complement C D complement, and the product form for this 1011 is A B complement C. A B complement C. Okay. Now we are taking OR operation among all these products. While taking OR operation among these products, it is BD or with A complement C complement D or with B complement C D complement or with A B complement C. So with the grouping of all these subQs, we are having coverage of all the minterms so that it is resulting as one possible minimal expression. It is resulting as one possible minimal expression. Okay. Now let us list here some products. Let us list here some products on this function. So let me list here the product Hx, the product Hy, the product Hz. The product Hx, the product Hx is BCD. The product Hx is BCD, and the product Hy is A complement CD, and the product Hz is A BD. The product Hz is ABD. I listed here few products Hx, Hy, Hz. Now let us take the question here as it is question first bit. So note down question is the first bit. For the given function f of ABCD, for the given function f of ABCD, where f of ABCD, the minterms are 1, 2, 5, 7, 10, 11, 13 and 15. For the given function f of ABCD, from the given product list Hx, comma Hy, comma Hz, for the given product list Hx, Hy and Hz, better wording, for the given function f of ABCD, from the given product list Hx, comma Hy and Hz, which are the products which are the implicants of the function f, which are the products which are the implicants of the function f, which are the products which are the implicants of the function f, which are the products which are implicants of the function f. So if this is a question, let us see the statement of the implicant. For a given Boolean function, a product we are naming as an implicant of the given function if the function f is covering the product h, we said. As and when the function f is covering the product h, then h is said to be implicant of the function f. So if you look here, Hx, Hy, Hz, these are the products. What are the products we are having here? Basically, these products are covering some minterms. are basically these products we are reading while grouping min terms. While grouping few min terms. The function is on 4 variables. The products what I listed here all are with 3 literals. So once there is a case, definitely we are having the grouping of the two cells, then only we are having these products. Let me check. This product I am having while grouping which 2 cells. For those 2 cells, based on the knowledge what we discussed earlier, B, C and D variables must be in complementary form and A is not common for that subcube. So if you look here, where we are having B, C, D is common. So from this you can see B portion this is, B portion this is. So that what is the 2 cells we will be marking. We are speaking 2 cells. Quickly I am talking as a 2 cells. The reason is function is on 4 variables, products with the 3 literals we already noted. Based on that we are speaking it must come from the group of 2 cells. The reason is the elimination we are having for 1 variable. Function was on 4 variables, the products 3 literals, the elimination was 1 variable. Once the elimination we are having for 1 variable, the subcube must come from the group of 2 cells. Which 2 cells we are looking here? B, C, D. Right? So B belongs to these 2 rows. So that what are the 2 cells we are marking? They are not coming from the first row and last row. They must be only from the middle 2 rows. Next variable is C. C belongs to only to this portion, to only these 4 cells. Earlier, while in the B it was 8 cells, now it is coming to 4. It means while reading 1 variable at a time, we are minimizing the range. So from these 4 cells, 2 cells will be giving the grouping of the 2 cells. We are having a product B, C, D. The next variable is D. D belongs to only to this portion. So that the B, C, D what we are having, which is coming with the grouping of 7 and 15 cells. With the grouping of the cells 7 and 15. Similar work we need to extend on other 2 products. A complement CD. A complement belongs to first 2 rows. C belongs to this portion and D belongs to this portion. A complement CD, look well, A complement CD. A complement CD, B is changing, it won't present, that is the thing what we are looking. So that is coming with the grouping of the cells 3 and 7. It is coming with the grouping of the cells 3 and 7. Similarly, ABD, if you check, A, B, D, A belongs to bottom 2 rows, B middle, D belongs to this portion. So ABD is coming the grouping of the cells 13 and 15. Is coming the grouping of the cells 13 and 15 ABD. Now if you see the product HX, we are having the grouping of the cells 7 and 15. This 7 and 15 both are the min terms to the function F. Based on this, HX is an implicant to the function F. It is an implicant to the function F. Coming to HY, we are having this product to the grouping of the cells 3 and 7. 7 is concerned, it's a min term. But coming to this 3 is not the min term. So that the function F is not covering the cell 3. The function F is not covering cell 3 means the function F is not covering the product HY. Hence, HY is not the implicant to the function F. Hence, HY is not the implicant of the function F. Similarly, HZ, if you look, HZ product we are having the grouping of the cells 13 and 15. This 13 and 15 both are the min terms to the given function F. Once the 13 and 15 are the min terms to the function F, the conclusion is the function F is covering the product HZ. So once function F is covering the product HZ, HZ is an implicant to the function F. HZ is an implicant to the function F. Hence, we are looking from the given product list, 3 products of course we are taking here, 3 products. For the given product list, out of these 3, only 2 products are the implicants to the function F. Only 2 products are the implicants to the function F. Hence, we are talking from the given list, This hx and hy are implicants, are the number of implicants to given function for the given product. Number of implicants for the given function from the given product list. Answer is 2. Question, note well. From the given product list, the number of implicants are only 2. This is not a implicant. So it's a way of checking a given product is an implicant or not. So what we are having is, if you want to check a given product whether it is an implicant or not, the work we need to do is, we are looking the product is covering which min terms. As and when those combinations are the min terms of given function, we are looking from the given product, the product is coming with a grouping of which cells. As and when those cells are the min terms of given function, then we are speaking the function f is covering that product. So we are speaking that product is implicant to the function f. In other way, whatever the cells, while grouping which cells we are having the product, if at least one of the cell is not coming to be the min term of the given function, then we are speaking the function f is not covering that particular product. Based on this, that product is not a implicant. Like this we are checking. So that to check a product is an implicant or not, the way is, you are looking quickly, the product is coming while grouping which cells. As and when those cells are the min terms of the given function, we are speaking that product is implicant. If at all we are looking any one of the cell is not the min term of the given function, we are speaking that product is not a implicant. So it's a means of the word implicant. So it is one of the important concept. This type of questions were there in the GATE CS papers itself. 2003 it was a question, 2008 it was a question, many times. So whenever we are having this sort of question, a function will be given, maybe function given like this, and some products may be given like this. Now while giving these such products, we are having a question, how many products are implicants? When we are having a question, how many products are implicants, this is a way you have to check. Okay, let us come to the next word. The next word we mentioned as prime implicant. Note down. Prime implicant is a smallest possible product term. Prime implicant is a smallest possible product term removing any one of the literal from which is not possible. I'm repeating. Prime implicant is a smallest possible product term removing any one of the literal from which is not possible. Again, let us look to the meaning of this statement on the same function while listing few products. So let us take again this as a question. So note down. For the given function f of ABCD, same function, from the given product list, how many products are prime implicants of the given function? How many products are the prime implicants for the given function? How many products are the prime implicants for the given function. So H1, H2, H3. The question is, for the given function f of ABCD, function is same as earlier, first bit, with the minterms of 1, 2, 5, 7, 10, 11, 13, 15. The question is now, from the given product list, this H1 to H7, how many products are prime implicants to the given function? How many products are prime implicants for the given function? Okay. So just take 1 or 2 minutes time and try. Read the statement well and try. From the given product list, we are looking for the given function, how many products are the prime implicants? So these are the questions you will be having in the GATE question paper. Conventionally, for university academic exams, such questions you may not be facing in the university exam papers, you may not be facing. But this type of questions will be having in the GATE paper, or for that matter, any good competitive technical exam, or maybe in interviews, you'll be having questions on this terminology like this. That terminology will be getting familiarity while solving these sort of questions with some examples. You'll be getting familiarity. So just noting the statements not enough. With the examples, you will be getting familiarity on this terminology. Okay, let us work now. I want to check this H6 is a prime implicant or not. I want to check this. The H6 product what we are having, it is BCD. It is BCD. In fact, we already verified. I'm coming from the first question, after that I'm coming here. So this H6 was basically where HX only. Here HX only this is it? So HX was implicant. It was implicant. Now the next check what we are having here is whether it is a prime implicant or not. Based on the statement of the prime implicant, it is mentioned prime implicant is the smallest possible product term removing of any one of the literal from which is not possible. Suppose if I am removing a literal from this, what is happening? If you know, later only we are concluding whether we can remove a literal or not from this. Suppose I am removing literal D from this. If I am removing literal D from this, what is happening? Let me check. If I am removing the literal D from this, the product is BC. When the product is BC, it must come from the group of how many cells? The product is BC, it must come from the group of how many cells? Definitely your answer must be from the group of 4 cells. Because while removing D, the product is BC, the function was on 4 variables, product is the 2 literals, so elimination will be for 2 variables. Once the elimination is for 2 variables, the subcube is with the 2 to the power of 2, that is 4 cells. And if you look, which are those 4 cells? So for those 4 cells, B and C must be common with the Boolean constant 1. So from the K-map, if you look, BC is common with the Boolean constant 1 is for this portion. So what we are looking, The product is coming with the grouping of cell 6, 7, 14 and 15. It is coming with the grouping of the cells 6, 7, 14 and 15. And we know well the combination 6 and combination 14 are not the min terms. Combination 6 and combination 14 are the max terms. So that if we remove the literal D from the product S6, the product is basically referring to a new function. It is basically referring to a new function. Once it is referring to a new function, the conclusion is removing of the literal D from the product S6 is not possible. Removing of the literal D from the product S6 is not possible. So once we are unable to remove the literal D from the product S6, based on this, we should not conclude the product is prime implicant, because the definition what we are having, prime implicant is the smallest possible product term removing of any one of the literal from which is not possible. No doubt we are unable to remove the literal D from this product S6. Based on this, you should not conclude it is a prime implicant. We are unable to remove this D. But we don't know from this product, may be possible to remove B. While removing B, if you check, the product is covering which cells? While removing B, the product is covering to which cells? If you see CD product, that is, if we are having CD, it must come from the group of these 4 cells, that is 3, 7, 11 and 15. It must come from the cells of 3, 7, 11 and 15, that column what we are having, right side, second column. So 3, 7, 11 and 15. We know the combination 3 is the max term to the given function. The combination 3 is not present in the given function means it is a max term. Or you can see from this, the function output is 0. So it is a max term. It means the product what we referred, this S6, from this product if we remove the B, the product is referring to a new function. Hence we are unable to remove even B from the product S6. We are unable to remove D, we are unable to remove B from the product S6. Based on this, of course, we are not speaking the product is a prime implicant. No doubt we are unable to remove this B and D, but we don't know from this product may be possible for us to remove the literal C. If at all we are removing the literal D from the product is BD. Once the product is BD, which is group of which cells, if you see, if it is BD, it must come from the group of cells. You can see from the map, it must come from the group of cells 5, 7, 13, 15. It was the one what we mentioned, 5, 7, 13, 15. It is coming from the group of cells 5, 7, 13 and 15. And we are looking here, these 5, 7, 13 and 15 all are min terms of the function f. 5, 7, 13, 15 all are the min terms of the function f. All 5, 7, 13, 15, all these 4 are the min terms of the given function f, or you can see from the K-map. It means from the product H6, we are able to remove the literal C. Once we are able to remove the literal C, then definitely the statement of the prime implicant gives the means the product is not a prime implicant. This is not a prime implicant, because from this product S6 we are looking a literal is possible to remove. The statement of the prime implicant is a smallest possible product term removing any one of the literal from which is not possible. It is not a smallest possible product term. The reason is we are able to remove C. Once we are able to remove C, it is not a smallest possible product term. Hence, the product S6 is not a prime implicant. The product S6 is not a prime implicant. Similarly, let me check H4 whether it is a prime implicant or not. The H4 is ACD. Let us work little fast. So from this product, if at all the D we are removing, if the D is removed from this product, the product is AC. Once the product is AC, which is group of which 4 cells? A and C must be common. Which 4 cells? The 4 cells must be, you can see from the map, they must be 10, 11, 14, 15. They must be 10, 11, 14, 15. Look to the map well. AC. Once it is AC, it is a group of 4 cells. Which 4 cells? If you look, it is a portion. A and C must be common only for this. Hence 10, 11, 14, 15. So 10, 11, 14, 15. If you see, the combination 14 is the maximum to the function f. Combination 14 is not the min term in the given function. Hence, it is a maximum. It means from the product H4, if you remove the D, the product is referring to a new function. It is referring to a new function. Hence, removing of the literal D from the product H4 is not possible. Once we are not able to remove the literal D from the product H4, it is not enough to speak the product is a prime implicant. No doubt we are unable to remove D, but we don't know about the other variables. So similar check we need to do on other variables what we did for H6 case. So coming to removing of the variable A. If the variable A is removed, the product is CD. Once the product is CD, earlier we are already having a work, quickly you can see. One is a CD, it is a group of cells 3, 7, 11, 15. It's a group of cells 3, 7, 11 and 15. And we know the combination 3 is the maximum. Combination 3 is the maximum to the given function f. Once the combination 3 is the maximum to the given function f, the conclusion is from the product H4 we are unable to remove A. We are unable to remove D, we are unable to remove A, even though we are not speaking the product H4 is a prime implicant, because we don't know from this product may be possible to remove C. So the similar check we need to extend even while removing C. While removing C, if you see the product is AD. When the product is AD, again it is coming from a group of 4 cells, and from the map if you see which 4 cells, AD common area, if you look here, AD common area is 9, 11, 13 and 15. 9, 11, 13 and 15. Look to the map. Go back and you can see AD common area is this. AD common area is this, means the cells are 9, 11, 13 and 15. And we know 9 is a maximum. Of course, other 3 are min terms, but 9 is a maximum. It means if we remove the literal C from the product H4, it is referring to a new function. Once it is referring to a new function, removing of the literal C from the product H4 is not possible. And the whole conclusion is, from this product H4, we are unable to remove any one of the literal. Once we are unable to remove any one of the literal from this product, the product is prime implicant. The product must be a prime implicant. Once we are unable to remove any literal from the product, H4 we are referring. The product must be named as prime implicant. It must be named as prime implicant. If you check like this, you will be having conclusion. H1 is a prime implicant, H2 is a prime implicant, H3 is a prime implicant, H4 is a prime implicant, anyway we verified, H5 is a prime implicant, H6 is not a prime implicant, and also we are recognizing this H7 also not a prime implicant. From the H7 we are having possibility to remove A. If you remove A, it is a BD, it's a BD, so we already verified. So that this S7, of course, from the earlier work, this S7 is nothing but HZ. So it is also not a prime implicant. The question is concerned, from the given product list, how many products are the prime implicants? So from the given product list, the answer to the number of prime implicants is 5. So first 5 products we are having as we are reading as the prime implicants. This S6, S7 are not the prime implicants. And with the knowledge of implicant, with the knowledge of this prime implicant discussion, be clear. To check a product is a prime implicant or not, to check a product is a prime implicant or not, first of all, the product must be implicant. If a product is not an implicant, making a verification whether it is a prime implicant or not, there is no means. It means there is no need to check HY. It is not an implicant. There is no question of it is to be prime implicant. So to check any product is to be prime implicant, first of all, the product must be implicant. It must be implicant. But every implicant may not be a prime implicant. The S, X, S, Z are implicants, but they are not the prime implicants. And the remaining products H1 to H5, all are the products. All these are the implicants and happen to be all these are the prime implicants. Hence, the conclusion is every implicant may not be prime implicant, but every prime implicant definitely an implicant. Every prime implicant is definitely an implicant, but every implicant may not be a prime implicant. It is a conclusion. Here our question is limited to identify from the given product list how many products are the prime implicants. How many products are the prime implicants. But when you are looking this as a question in the examination point of view, in the GATE question paper, very regular, very frequent question, very common question. You refer the previous GATE solution book, couple of questions you will be finding. You will be having a question little differently, note down as a third bit. For the given function f of ABCD, for the given function f of ABCD, the same function we are referring. For the given function f of ABCD, how many products are prime implicants? For the given function f of ABCD, how many products are prime implicants? It is a question, or it can be a question. For the given function f of ABCD, the number of prime implicants as a dash, as a numerical question. For the given function f of ABCD, the number of prime implicants like this. Either way, it is one and same, work is concerned. So function may be given like this in the question paper. Function may be given like this, one of the simplified form. It may not be minimal always. It may be sometimes simplified form also. So function may be given like this, may be given like this, or function may be given sometimes in the K-map. So while giving a function in any one of the format, we are having a question for the given function f of ABCD. How many products are the prime implicants is a question. How many products are the prime implicants to the function? That is the question. If you come to this previous question, second bit, our question was limited to the given list. Our question was limited to the given list. I may not be written few of the products here. I may not be listed few of the products here. Those products may also result as a prime implicants. Those products also may result as prime implicant. When the question is coming as what we noted just now, the number of prime implicants of given function, without missing any product, we need to speak the answer. Without missing a single product, we need to speak the answer. How many products will be resulting as prime implicants? So be clear. Earlier question, second bit was limited to the given product list. From the given list, the question we took, how many products are the prime implicants? But the third question, third bit what we took is, for the given function you have no product list is given to you. क्वेश्चन पेपर में प्रोडक्ट लिस्ट नहीं दिया आपको. क्वेश्चन पेपर में क्या दिया? ओनली फंक्शन दिया. फंक्शन में भी गिवन लाइक दिस और मे बी इन द के मैप. वो फंक्शन देके आपको क्या पूछ रहा? फॉर द गिवन फंक्शन हाउ मेनी, फॉर द गिवन फंक्शन फॉर अ गिवन फंक्शन हाउ मेनी प्रोडक्ट्स आर द प्राइम इम्प्लिकेंट्स, नंबर ऑफ प्राइम इम्प्लिकेंट्स फॉर द गिवन फंक्शन. ये है क्वेश्चन आपको अभी. सो दैट some products, if at all you are skipping here, while skipping those products, if you speak answer as a file, it may be coming to be wrong. It may be coming to be wrong. So some products may be skipped here, so that without skipping any product, you need to speak the answer now. And I'm mentioning This question is coming, say, with the weightage of 1 mark. Once the question is coming with the weightage of the 1 mark, why I am mentioning the weightage of 1 mark, you can understand. I'm talking about the time aspect. If the question is the weightage of 1 mark, we supposed to answer to this question within 1 minute. For a 1 mark question, if at all we are spending 4 or 5 minutes, it is no much worthy as far as the exam is concerned. So 1 mark question we supposed to answer within 1 minute. So to answer this question within 1 minute, making a product list something like this and making a verification something like this, just not possible within the 1 minute. Within the 1 minute, you can't do all this sort of work what we did here. No doubt, we discuss all these things to understand the means of the prime implicant. To take the means of the prime implicant or to explain the means of the prime implicant, I did all this work. But definitely in the exam hall, you are not getting enough time to do all this work within 1 minute. Making a product list something and checking like this, you can't get enough time. But it is coming as a question of 1 mark, means definitely there may be some other alternative approach to speak the answer within the 1 minute. See, paper setter just is not giving a lengthy question for 1 mark. He won't give because he's also experienced person, and how much time you as a student you will be spending as per the pattern, they know well while studying the paper. So the question needs really this sort of work, that is not going to be the question of 1 mark. It may be given with the weightage of something else. So if the question is coming with the weightage of 1 mark, means definitely some other alternative procedure may be there, or some other alternative approach may be there to speak the answer within 1 minute. It is possible to speak the answer within 1 minute, then only they will give this as a question. So just think how we are giving the answer to this question within 1 minute. And if you keep attention well, definitely the work what we did till now with all this explanation, you can speak easily the answer to this within 1 minute. Luckily, if at all function is available in the K-map, luckily the function is given in the K-map in the question description. To answer this, we are not in need of even 1 minute. We are not in need of 60 seconds. Possible to answer to this question with few seconds, probably 15-20 seconds may be enough to answer. I am providing all these inputs. Based on these inputs, just try to make the answer, try to give the answer with less time. Try to think how we are giving answer with less time. With all the things what we discussed, try to put an idea how we are giving the answer with less time. As I said, just in 15-20 seconds, we can speak answer if the function is available in the K-map, I said. Just think. Just try to look how we are speaking this. I will give some more hint. How we are speaking answer to this, I will speak some more hint. The product H1 is coming with a group of which cells? Definitely 4 cells. Which 4 cells? You can see from the map. It is coming with the group of cells 5, 7, 13, 15. And this product A complement C complement D is coming with a group of cells 1 and 5. This product B complement C D complement is coming with a grouping of cells 2 and 10. From the map we are giving nothing else. For clarity, you can see the map. Go back and see the map, or if at all you are already noted in the notes, hopefully you are doing that. You can see the notes. So for the map, if you can see. Okay. So S3 is coming the grouping of the cells, this 2 and 10. Similarly, H4, if you look, H5, if you look, tell me. So H5 is A, B complement C, readily available there, 10 and 11. ACD, hopefully you are speaking. ACD is coming with a group of cells 11 and 15. The group of cells 11 and 15. I'm having this 11 and 15 It is also largest size subcube. It is not coming to be part of any other subcube. So I can see this subcube 11, 15. So the grouping of 11, 15 I am having. And this H6, H7, if you see, H6 is X only, that we are having the grouping of the cells 7 and 15. And this we are having the grouping of the cells 13, 15. Again, back to same question. How we are speaking the answer to the number of prime implicants with less time, knowing the function in the K-map. While knowing the function which is available in the K-map, how we are speaking the answer to the number of prime implicants with less time. So what you are looking at the board with this information, you can make a correlation and you can speak answer easily. You must make proper correlation, the work what we are having and what the question we are talking. So self-learning with these hands will make you feel you are doing on yourself something that will motivate you to do best, that will motivate you to learn best, and that will motivate you to do many problems. That is the approach you need to follow. So dependency, if you reduce yourself, then definitely your learning will be best. So hints what I given with that, hopefully many of you might having the conclusion now by this time. Let me speak now. This H7 is not a prime implicant. If you look, this 13, 15, what we are having here, it is coming to be the part of this H1. But if you look here, this 1, 5. 1, 5 is not coming to be the part of any other subcube. Similarly, if you see this 10, 11, 10, 11 also not coming to be the part of any other subcube. 10, 11 also not coming to the part of any other subcube. But if you see this S6, 7, 15, we are looking, this 7, 15 is coming to be the part of the largest size subcube. This 7, 15, S6, S7, 13, 15 coming to be the part of the largest size subcube. But remaining, if at all you are looking, none of the remaining subcubes are coming to be the part of any other largest size subcube. So the answer is very simple. When we are having a question, the number of prime implicants of the given function, if the function is given in the K-map, the work what we need is simply with a pencil you need to mark all possible largest size subcubes. While counting all possible largest size subcubes, you are speaking the answer to this question as so and so. So to identify the number of prime implicants for the given function, by using pencil we are marking all possible largest size subcubes. While counting all these possible largest size subcubes, we are speaking answer to this question as so and so. So if you come to this example, if you look, marking all possible largest size subcubes, we are having 1, 5, one largest size subcube. This 2, 10, one possible largest size subcube. This 10, 11, one possible largest size subcube. This 11, 15 also one possible largest size subcube. As long as it's not coming to the part of any other subcube, it's the largest size only. So by this time, if at all you're looking how many we counted 2 cell subcubes are 1, 2, 3, 4. No more 2 cell subcubes. We are having here one 4 cell subcube. We are having here one 4 cell subcube. So one 4 cell subcube and 4 2 cell subcubes. On the whole, total how many largest size subcubes? On the whole, we are having 5 largest size subcubes. Hence, answer to this question, number of prime implicants to the given function, that was the question what we took as third question, the third bit, sorry. The answer to this question is 5. Answer to this question is 5. So hopefully they're accepting. If the function is already given the problem description, the question description, the problem is, the function is already available in the K-map, then definitely to answer this question, you are spending maximum 15-20 seconds time just to mark the largest size subcubes. By chance, you are having the question may be like this or like this. Of course, there is no option. You have to develop the K-map. To develop the K-map, you may be taking time, but to identify the prime implicants, you are not taking time. So, like this, we are speaking the answer to this question with less time. So note down. Number of prime implicants to the given function are equal to number of prime implicants to the given function are equal to number of prime implicants to the given function are equal to number of all possible larger size subtubes in the K-map. Number of prime implicants to the given function are equal to number of all possible larger size subtubes in the K-map. Number of all possible larger size subtubes in the K-map. Number of all possible larger size subtubes in the K-map. So just with a highlight properly with a box or somewhere you make a note. Very important. So it is, I said, as a question of 1 mark. Most of the times it is coming the weightage of 2 marks. So if you are understanding this example well, and of course we are going to do few more examples, you can score the 2 marks just within 15-20 seconds. If you are having this clarity, just scoring 15-20 seconds, that is enough to give the correct answer. So what I mentioned, number of prime implicants to given function are equal to number of all possible larger size subtubes in the K-map. So whenever you are speaking the larger size, the condition you should not remember. When you are marking a 2-cell subtube, the condition is it should not come as a part of any larger size subtube. That condition we should not forget. Okay. Sometimes you may be having a question, the prime implicant set of the given function. So let's me give as a question. Note down. It is fourth bit. For the given function f of ABCD, for the given function f of ABCD, for the given function f of ABCD, write the prime implicant set. Write the prime implicant set. Write the prime implicant set. It is a question. So function is same, prime implicant set. So this may be a question and the multiple choice as for the given function f of ABCD, the prime implicant set is some ABCD options you will be looking. So each option will be having some product list. So which product list is resulting as a prime implicant we need to identify, that we can talk the work what we did here. Coming to this question, the prime implicant set is BD, A complement, C complement D, B complement C, D complement, ACD, A, B complement C. So this is the prime implicant set for the given function f of ABCD, the example what we are looking. Okay. Now I can speak the condition what I mentioned earlier in our earlier discussion, the basic part of the K-map what I discussed. One of the condition what I mentioned was when you are marking a subcube of 2 to the power of m cells, I said we must take care it should not come as part of any larger size subcube. It was the statement what we noted. Now we can understand with all this work why this condition is required to follow while marking subtubes, why we are not going randomly, why we are marking subtubes with this condition, we can understand. To understand this, you go back to the statement of the minimal expression. Go back to the statement of the minimal expression, turn your pages and look, or you rewind the video and go back and see. The statement of the minimal expression what we mentioned is, minimal expression is the expression, it must contain a minimum number of terms. That is one condition. And each product with a minimum number of literals. Second condition is concerned to this now. Each product must contain minimum number of literals. That is the condition what we are talking. Each product must contain with a minimum number of literals. Suppose I am marking a subcube something like this as 7 or something like this as 6. These products, corresponding products are not with the minimum number of literals. But if I am taking the subcube something H5, this 10, 11 or 11, 15 and so, these subcube products are resulting as prime implicants. So from all this work, if at all we are looking here, the understanding is this 13, 15 is coming as a part of this larger size subcube. But if you take this 1, 5, it is not resulting to be the part of any larger size subcube. If you take this 10, 11, it is also not resulting to be part of any larger size subcube. But if you take 7, 15, that is S6, it is coming as a part of the larger size subcube. So conclusion is, as and when we are marking the larger size subcubes, guarantee the subcube product is the minimum number of literals. Guarantee the subcube product is the minimum number of literals. To write the minimal expression, our requirement is we must use products, they must be with a minimum number of literals. The products are guaranteed with the minimum number of literals if and only the subcubes what we are marking, they are not coming to be the part of any larger size subcube. As long as the subcube is not coming to the part of any larger size subcube, we are guarantee this subcube product, we are guarantee the subcube product is a prime implicant. In fact, it is a reason why we said this condition while marking the subcubes. For reading the minimal expression, we must use only smaller, we must use the products which minimum number of literals. The products with the minimum number of literals are guaranteed if and only the subcubes what we are marking, they are not coming to the part of larger size subcube. In other way, for reading the minimal expressions, if at all we are using the prime implicants, we are guarantee the products are with the minimum number of literals. For reading the minimal expressions, we use the prime implicants, we are guarantee the products are with the minimum number of literals. So for reading the minimal expression, this new terminology we can speak. For reading minimal expression, we must use only prime implicants. A product is guaranteed to be prime implicant if and only if you follow this condition. So it's a means of the condition what we mentioned earlier. So finally make a note and keep in somewhere with a highlight in the box. In the minimal expression, we must use only prime implicants. In the minimal expression, we must use only prime implicants. Okay, make it in a box. So once you are using the prime implicants, the minimal expression, guarantee the products are with the minimum number of literals. The products guarantee as the prime implicants if and only if you follow this condition. Now, let's come to the next word. The next word I mentioned, essential prime implicant. Note down the definition of essential prime implicant. Note down. Essential prime implicant is a prime implicant. Essential prime implicant is a prime implicant. It must cover at least one min term. It must cover at least one min term which is not covered by any other prime implicant, which is not covered by any other prime implicant. Essential prime implicant is a prime implicant. It must cover at least one min term which is not covered by any other prime implicant. It is a statement of essential prime implicant. So on the same example, let us take now also as a question and let us try to look. Note down. For the given function f of ABCD, for the given function f of ABCD, the same function for the given function f of ABCD, how many number of products are essential prime implicants? For the given function f of ABCD, how many number of products are essential prime implicants. Are essential prime implicants. So, same function. How many number of products are essential prime implicants is a question. You can try the statement what I given with that, and if the available earlier work you can speak. Okay. So we are looking some products on the board. Let me see which are the products which are the essential prime implicants, which are not. Can we check these H6 and H7 as EPIs, as essential prime implicants? Can we check? The answer to this question must be no. If you want to check a product is to be EPI, first of all it must be PI. If the product is not a PI, definitely it is not going to be EPI. So no need to check this H6 and H7. Same thing we were talking earlier with the PI also. Once the product is not a implicant, there is no need to check whether it is a PI. To check a product is PI, first of all they must be implicants. Similarly, to check a product is to be EPI, essential prime implicant, first of all it must be PI. These are not PIs, so that no need to check this. There is no means of checking this. Let us check whether H4 is EPI or not. So H4, what we are having ACD. So what is the statement we are having for EPI statement? Essential prime implicant is a prime implicant. It must cover at least one mentum which is not covered by any other prime implicant. The H4 is covering this 11 and 15. If it is to be EPI, it must cover at least one of the mentum. It should not be covered by any other prime implicant. It means we must see at least one of the mentum should not present in any other subcube. As and when at least one of the mentum which is not present in any other subcube means that particular mentum will be covered by only this H4. It is the means. As and when at least one of the mentum we are not reading in any other subcube, we are guarantee that mentum will be covered by only that particular subcube. Hence, that subcube product becomes EPI. If you check here now, 11, if you see, 11 covered not only by this H4, also covered by H5. Hence, as far as the coverage of the 11 is concerned, guarantee H4 is not a EPI. We don't know because of 15, but because of 11, with this check, we are having a conclusion because the 11 coverage, the H4 is not a EPI. Coming to this 15, we are looking which is covered not only by H4, 15 also covered by H1. So it means H4 exclusively not covering any one of the mentum. As and when H4 is not covering, as long as H4 is not covering any one of the mentum exclusively, then guarantee this H4 is not a EPI. Then guarantee this H4 is not a EPI. Similarly, let us check H2. H2, if you see, the mentum 5 coverage, if you see, the mentum 5 coverage we are having not only by H1, by also, not only by H2, by also H1, because in this subcube also we are looking. Hence, as far as the coverage of the mentum 5 is concerned, H2 is not a EPI. We don't know because of 1, but based on check, not because of 5. If you look for 1, the mentum 1, are you looking in any other subcube? Mentum 1, are you looking in any other subcube? The answer is no. The mentum 1 we are not reading in any other subcube. So mentum 1 is not present in any other subcube means the mentum 1 is not covered by any other prime implicant. In other way, the mentum 1 exclusively covered by the product H2. As the mentum 1 is exclusively covered by the product H2. The mentum 1 exclusively covered by the prime implicant H2. Based on this, as far as the coverage of the mentum 1 is concerned, the product H2 is essential prime implicant. Similarly, for H3, if we check, the momentum 10 is concerned, covered by more than one prime implicant, but momentum 2 is concerned, it is not covered by any other subcube. Momentum 2 is not present in any other subcube. It means it is not covered by any other prime implicant. Hence, as far as the coverage of the momentum 2 is concerned, H3 becomes EPI. Let us look to the H5. H5 is concerned, 11 we already verified, it is covered by more than one prime implicant. 10 if you see, it is also already verified, it is also covered by more than one. It means H5 exclusively not covering any one of the momentum. Once it is not covering exclusively any one of the momentum, H5 is not a EPI. Come to the H1, 5, 7, 13, 15. If you look here, the coverage of 7 and 13, coverage of the 7 and 13, if you see, they are not present in any other subcube. So, the coverage of the 7 and 13 is only by the product H1, is only by this prime implicant H1. Hence, the coverage of the 7 and 13 are concerned, the H1 is essential prime implicant. H1 is essential prime implicant. Hence, out of 5 prime implicants, we are reading the first 3 products, first 3 prime implicants are essential prime implicants. Out of 5 prime implicants, first 3 prime implicants are essential prime implicants. Hence, the answer to this question is 3. The question was, for the given function f of a, b, c, d, how many products are essential prime implicants? The answer to this question is 3. Again, it may be a question of 1 mark. Again, it may be the question of 1 mark. So, how to answer to the number of prime implicants? How to answer to the question number of prime implicants? We already discussed. The answer to the number of prime implicants we are having while marking all possible larger size subcubes in the K-map. Now, the question what we are looking is number of essential prime implicants. Again, we considered it is coming as a question of only 1 mark. With all this work we mentioned it is a 3. But all this work what we discussed, it is taking more time. It is taking lengthy time. Once it's a question of 1 mark, definitely there must be some other alternative approach to speak the answer on this question. So, can you recognize what is the alternative approach to speak the answer to this question with less time? Can you identify what is the approach you need to follow to identify the answer to this question with less time? The approach is similar to the earlier from the work what we are having here to map how we are dealing. You need to make a correlation how you are looking. So prime implicant, what is the correlation we did? The same way you have to talk here also now. So you need to take a question now as why this subcube product is not a EPA? Why this subcube product is a EPA? Why this subcube product is a EPA? Why not this? Like this, if you take the question, you will be having answer. So you can see from here, suppose H5 we are looking, H5 is A, B complement C, it is the grouping of the cell 10, 11. Suppose if we look H1, it is a grouping of the cells 1, 5. The observation is, through cell 1 single cross, coming to this H5 case, we are having through cell 10 as well as through cell 11 more than 1 cross marks. More than 1 cross marks. Similarly, if you look to the H2, it is a group of cells 1 and this group of cells is H2 I am talking. H2 group of cells 2 and 10. So what we are looking through cell 2, no overlapping. But come to the H4. H4 is group of cells 11 and 15, more than 1 cross marks. in each cell. So understanding is, if at all we are having any subcube in which through at least one cell, if at all there is no overlapping, if we are having any subcube in which through at least one cell without overlapping, then definitely because of that cell or because of that min term, that subcube product becomes essential prime implicant. That becomes essential prime implicant. Through cell 1 no overlapping, it is the reason why it was EPI if you look to the H2, right? And if you look to the H3 through cell 2 no overlapping, it is the reason why it is EPI. And if you look to the H1 through cell 7 and 13 no overlapping, it is the reason why it is EPI. But if you look to the H4 and H5, there are overlapping we are having in the 10, 11 as well as 11, 15, so that H4, H5 are not EPIs. Hence, the function is given in the question paper, in the question description, function is available in the K-map. To speak the answer to the number of EPIs, the work is after marking or after knowing the answer to this work is nothing, zero. There is no need of any time required. So what we need to do, just we need to scan the subcubes in which as and when we are looking at least one cell without overlapping. All such subcubes we are counting and we are speaking answer to the number of essential prime implicants. After knowing the answer to the number of prime implicants, we are knowing the answer to this while marking all possible larger size subcubes. Later we are scanning the subcubes. If at all we are looking in any subcube at least one cell without overlapping, that subcube product we are reading as EPA. So if you look here, we are having 3 such subcubes in which at least one cell we are looking without overlapping. Hence answer we are having as number of essential prime implicants equal to 3. So like this, without spending even single second, possible for us to speak the answer to the number of essential prime implicants after knowing the answer to the number of prime implicants. So better note down the statement. Number of essential prime implicants, the number of essential prime implicants to the given function, number of essential prime implicants to the given function are equal to number of all possible largest size subcubes, number of all possible largest size subcubes in which at least one cell without overlapping, in which at least one cell without overlapping, in which at least one cell without overlapping. Number of essential prime implicants to the given function are equal to number of all possible largest size subcubes in which at least one cell without overlapping. That is statement possible to give. So if you look here, based on the statement, this is one largest size subcube, cell 1 without overlapping. This is other cell 2 no overlapping. This 4 cell is another one, through 7 and 13 overlapping. Hence answer to this question is 3 essential prime implicants. So you can take the question here also, essential prime implicant set. Essential prime implicant set, definitely we are speaking as BD, A complement C complement D, B complement C, D complement. This is the essential prime implicant set. So finally, with all this work, our concern is reading the minimal expressions. Our concern finally with all this work is reading the minimal expressions. So note down. Essential prime implicants must present. Note down. Essential prime implicants must present in all possible minimal expressions. Essential prime implicants must present in all possible minimal expressions. Why it is so? Let me talk little later. So, but the statement try to accept. The statement what I am talking is essential prime implicants must present in all possible minimal expressions. Coming to this question, note down. Write all possible minimal expressions write all possible minimal expressions for the function f of ABCD. Write all possible minimal expressions for the function f of ABCD. The function is same minterms what we took earlier for earlier bits. Same minterms. So function is on the variables ABCD. The minterms 1, 2, 5, 7, 10, 11, 13, 15. These are the minterms. The statement what we noted is essential prime implicants must present in every possible minimal expression. So let me write the EPIs first in the expression BD, A complement C complement D, B complement C, D complement. Now let me check. Because of these essential prime implicants, which are the minterms we are having coverage? Let me check. BD product basically covering 7 and 13. This is the given function. For this given function, the minterms 7 and 13 are covered by H1. Right. A part of 7 and 13, it is also covering 5 and 13. 5 and 15. 5 and 15. And the next product, A complement C complement D, it is also EPI. It is basically covering 1. A part of 1, it is also covering 5. But this happens so 5 is already covered by earlier EPI. Right. Next EPI we are having B complement C D complement. B complement C D complement basically covering 2. A part of 2, it is also covering 10. So out of 8 minterms, 7 minterms are covered by essential prime implicants. Out of 8 minterms, 7 minterms are covered by these EPIs. Only one minterm, that is the minterm 11. Only one minterm, that is the minterm 11, which is not covered by EPI. Now, if you take the question, why essential prime implicants must present in every possible minimal expression? So, for example, this A complement C complement D, if you see, to cover the minterm 1, it is the only one product available. To cover the minterm 1, it is the only one product is available, A complement C complement D. In fact, there is a reason why we name this product A complement C complement D as EPI. Hence, the function is having 1 minimal form, 2 minimal forms, or 10 minimal forms. In all those minimal expressions, to cover the minterm 1, the product A complement C complement D must be there, must present. The same reason holds good for any other EPI. For any other EPI, the same reason holds good. So, function minimal form is not completed. The EPIs are covering out of 8 minterms, 7 minterms, 1 minterm 11 is not covered. So, to cover the minterm 11, we are having possibility to use maybe this H4, we are having possibility to use H5. Suppose if I am using H4, it is one possible minimal expression. If I use H5, it is giving other possible minimal expression. If I use H4, it is giving one possible minimal expression. If I use H5, it is giving other possible minimal expression. So, a part of this, are you reading any other minimal expression? A part of this, are you looking any other minimal expression? The answer to this question is no. These are the only 2 possible minimal expressions for the given function f. These are the only 2 possible minimal expressions for the given function f. So, function is having these 2 minimal forms. Just look what comfort we are having the K-map. The same work at all we are doing using properties. There was no guarantee for us to read the minimal forms. By chance we are reading also, we may not be reading all possible minimal expressions. There is no guarantee, first of all, to read the minimal forms. If you are reading also, we may not be reading all possible minimal expressions. But using K-map, if at all we are looking here, using K-map, that is not the problem. We are guaranteed to read the minimal form, and of course, we are guaranteed to read all possible minimal expressions. That is the reason why we said the K-map is one of the systematic procedure for reading the minimal expressions. Based on this only we mentioned the K-map is one of the systematic procedure for reading the minimal expressions. So on the whole, the function is having here two minimal forms. It is having two minimal forms. It is the final work what we are looking from this K-map. So from this K-map example, we started the work with all these words. So we took what the means of implicant, prime implicant, essential prime implicants, and how to identify the number of prime implicants, how to identify essential prime implicants, and when we are naming a product is implicant, when we are naming a product is a prime implicant, when we are naming a product is EPI. And with all this knowledge, we are speaking now how to write the minimal expressions. So it is a correct approach for reading all possible minimal expressions, not zigzag, not randomly. Okay. Let us take a hypothetical question. Consider H4, H5, both are covering uncovered momentum 11. But assume this is coming with a group of cells 4. It is coming with a group of cells 4. Whereas H4 is coming the group of cells 2. Whereas H5 is coming the group of 4 cells. Both are covering uncovered momentum 11. Now a small question. If at all it is a situation, I said only it is hypothetical situation, assumption only. Hypothetical. This hypothetical situation I said, assumption only. If at all it is a situation, then try to speak the answer for the given function f of ABCD. For the given function f of ABCD, function will be having how many minimal forms? Function will be having how many minimal forms? If it is the situation, as I said, it is only hypothetical situation. In this case, in this example, it is not happening so. But in this hypothetical situation, for this function, if you speak, how many minimal forms? The answer to this, hopefully you are answering everybody. Answer is only one minimal form. Only one minimal form. If you are having only one minimal form, means you will be using among these two only one. So which one we supposed to use? We supposed to use not H4. We must use H5. To cover momentum 11, we must use H5, not H4. Why not H4? The answer is simple. H5 is the group of 4 cells, whereas H4 is the group of 2 cells. Once the group is 4 cells, the product is with lesser literals. As and when the subcube is the larger size, the product will be with lesser number of literals. As and when the subcube is the larger size, the product will be with lesser number of literals. Hence, we must use only H5, not H4. Of course, how we are speaking, if you take as a question, look to the definition of the minimal expression. The definition of the minimal expression we are having as the minimal expression must contain a minimum number of terms. That is the first condition. Second condition is each product must be with a lesser number of literals. So, why we are choosing H5? The answer to this we are having with the second condition. Each product must be with lesser number of literals. H5 is having, in this hypothetical situation, H5 is having lesser number of literals comparing the H4 to cover 11. It is the reason why we are choosing H5. It is the reason. If at all this hypothetical situation is true, then answer will be only one for this function. Okay, the answer is only 1. But it is not the scenario in this example. In this example, both the subcubes are the same size. Hence, if we use any one of these, it is sufficient. Because of this, a part of the essential prime implicants, we are using any one of these. So, answer for the number of minimal expressions we are reading as 2. As 2. So, this topic what we discussed, K-map, with respect to all this terminology, you, if at all, with a single watching of the video, if you are following, well and good. Hopefully you will be following. Or somewhere you are getting little gap, little time you are taking to understand all this. Try to watch more than one time. Make proper notes. If required, pause and make the notes. And finally, you make proper notes. So you feel more comfort with this knowledge. Any K-map question you feel on fingertips. Any K-map question, if at all present in the exam or somewhere else, you will be giving answer to any sort of K-map question on a fingertips without time spending. You will be giving answer. You will be having a better edge guarantee for that. Okay. So this topic, let us stop here. We need to continue some problems with the K-map in the next video.